Should I stop sharing for the time being? Or
Yes, sir.
yeah, I will stop sharing for the time. चालू करते हैं ठीक.
Okay, so let us start the session without further ado. So, good morning, everyone. Let us start. Okay, fine. So there was some glitch from my side. Okay, so good evening, everyone. On behalf of Innovation Cell and Entrepreneurship Cell in NIT Raipur, I welcome you all to the iTalk series on data analytics. I am Sikta Sharma, and I'm today's host for the session. It gives me immense pleasure to introduce you to the speaker of the series, Shrikant Velankar. He is the professor of electronics engineering at Vidhyalankar Institute of Technology. He has a total experience of 34 years, of which 16 years is in industry and teaching experience of around 18 years. He has published around 17 technical papers and has co authored 11 books on several topics. He has a patent and a copyright in his name. Further, one patent, three copyrights, and two designs are in progress. He has varied industry experience and he's also on consulting board of four MSME companies. He has carried out 20 plus industry projects, of which three are based on Python and data science. He has also conducted several skill development courses for students, industry, and corporates in Python, data science, embedded systems, IoT, and Industry 4.0. We are honored to have you, sir. So, without further taking much more space, I would like to give the space to you, sir. You may start your talk.
Okay, thank you very much, Sita. We'll be starting today. This, I think, is totally a 3 weeks program that you are conducting, and it's a very comprehensive program and data analytics, of which I would say that I would be carrying through the first week, which essentially constitutes the data analytics from the point of view of Python. So I would say that it is related to Python and Python tools that we are using in data analytics. And of course, subsequently, there you will be exposed to many more advanced methods and details related to data analytics in various real world scenarios. So, as far as my this lecture series from today to Friday is concerned, it will be consisting of obviously 5 lectures every day, same time, and I will be covering Python. First of all, introduction to Python, then some basics or fundamentals of Python. Then we will move on to certain ways in which the Python programming is carried out, the main areas in which the Python programming is carried out. Obviously, since it is huge area, I will be limiting myself to certain data and control structures which are there in structured Python. And then we will move on to see a few tools which are there, which are required in different stages of data science and data analytics. such as maybe data processing, data pre-processing, data visualization, reporting, etc. So different stages. There will be different tools of Python that will come to your help, and we will be looking into them. So I will straight away start my presentation, and I will also turn my video off to have the proper bandwidth, because major part of this, although I'm going to start with the presentation, but by and large, it will be hands-on on Python tools. So maybe first 10 to 15 minutes, we will be looking into some very basic things related to Python, and then obviously we will shift to the Python interpreter and start seeing quite a few things in there. So I will start sharing my screen. Okay, so I hope that the screen is properly visible, and we are starting off with the presentation for Python and Python tools for data analytics. First of all, I will thank National Institute of Technology, Raipur, its faculty members and student coordinators of Innovation Cell for arranging this comprehensive lecture series. And of course, I am starting the first leg of that. Okay, so without wasting much time, because actually, whatever area is there, which is supposed to be covered, it can have pretty big details, and time is going to be a real crunch, I would say, and we will try to accommodate things uh, as far as possible, or whatever maximum that can be covered in these sessions. So
Sir, I would
we
like
will.
to interrupt a little. So your screen is not visible.
mm, just a minute. Huh?
Sure, sir. Sure, sir.
Is it visible or no? Still not.
No, sir.
Oh, just a minute. I will try to turn off other devices which are there on the router uh, to get the maximum bandwidth possible here. I don't know. Scenario. Now it has come.
Sir, would you again share your screen? Maybe then things will work out.
Just a minute.
Yes, sir. It's visible now.
Okay. So is the NIT Raipur iTalk title visible now?
Yes, sir.
Okay. Thank you. Fine. So, as I said, without consuming much time, we will straight away move on to this, as the subject is pretty vast. And I will be just showing you the agenda in basic. I would say that it will be divided into two parts. Part A, which is essentially the Python module, in which we will cover Python data types and console IO basics. the various control structures and conditional statements which are there in Python, different types of Python sequences, and then a bit about the Python functions, modules, and their special functions. So I would say that this would definitely require a lot of time if we take it in good details, but still a good level overview. We will be consuming around 2 or slightly more than 2 days on this. And if time permits, we'll also see file access to the Python in Python. And then in second part, we will see the data science and analytics module, in which we will be seeing different tools such as NumPy, which is used for data handling, essentially number churning. Then Pandas, which is essentially used for it is something like a database in the memory where you can carry out different types of pre-processing and processing functions. Uh, then we are having the Matplotlib tool, which is for data visualization, and then for performing data analytics using statistical methods and techniques and tests, we'll be using scikit-learn tool. So these are the four tools which should take us through another 2 days. So it will be a stuff of around 4 to maybe around 4.5 days, and then we will end up last 1.5 hour with one real world example, taking a real world data set and trying to perform certain data analytics functions on the real world example. So that will be the spread of this lecture series, I would say. Let's start right away with Python and very quickly run through some of the Python basics. We know that Python is an interpreted language, so every line is interpreted and executed. So there is no need of doing pre-compilation, uh, and you can run it as a line by line in terms of the executable code. It is highly interactive. We are able to interact with the Python interpreter. There are various ways or methods by which it can be carried out. We will be seeing that, and interaction with Python interpreter, both in IDE environment as well as from the command prompt is possible. And then it is an object-based language. It supports both structured programming model as well as object-oriented programming model. However, heart to heart, we can say that in Python, everything is object. Okay, in fact, many of the data variables, other than maybe the very basic 2 or 3 variables, all the data variables also, they are objects in themselves, as we will see, and I will show you some what you can say visible interpretations where we can very easily see that okay, this is actually a data variable, but it is an object essentially. So that is why it is typically called as the object-based language, because everything gets presented to the programmer and many times to the user, data analytics user, because data analytics user is required to handle so many different types of tools, and most of the tools have their objects. So that is how we call it to be object-based. Then it is a beginner's language in the sense Python is very easy to learn, adapt, and we are able to start doing Python programming pretty quickly. And we also having a very systematic and structured approach in which we can go about it. So it can be said to be beginner's language. Moving ahead, Python has its environment, which is required to be running on your system. Typically the Python version, whatever 3.8.6 or 3.9, whatever versions which are there, the latest Python versions, its environment will be there. It will be installed, and then it can be accessed in different ways, such as interactive way. You can do it from command prompt. You can also do it from the application packages which are having graphical user interface. or what we call it as the complete integrated development environments. So GUI and ID based operations for Windows. Of course, it is possible for doing it the same way for most of the operating system environments. It is available for Unix, it is available for Linux, and of course for Windows. So we can put the code in Notepad++ and then execute directly in the Python environment. Or there can be IDEs like PyCharm, Spider, Jupyter Notebook, which can present the Python in a notebook form where you can also carry out your notings on that, and the execution cells can be performed and also preserved later on, so as if the entire thing looks like a chapter. And then you are having a Python and many others which are there uh, included into a full package suite like Anaconda. So you are having a host of ways in which we can enter into Python environment. Also, simple packages are available which can run from directly from command prompt, such as interactive Python, that is IPython, and so on and so forth. We can also run Python online. So you are having program is the environment which we can very easily be used for major part of Python learning. Certain areas may not be possible, but major part of the Python learning can be carried out using online tools as well. And there was a very good tool, but recently I have started seeing is that it is no more open source. They are offering it only to those who are having IBM courses. So, but till recently, like say last 3 or 4 years, for students, I was, and even for industry. In fact, I was conducting the courses laboratories on labs.cognitiveClass.ai, which is by IBM, but unfortunately it is no more available, so let's not talk much about it. Okay, moving ahead, what we are going to see today first is basic console IO, then Python data types, and the operators which are supported by the Python interpreter. In addition to that, we will also see certain control structures. So, in addition to data types and operators, we will also see different control structure. Okay, so this is what the first area that is what we will cover, and probably it is having so many things and variations. So it should suffice us through the today's lecture. I will try to do things the best possible way, but still, usually it has its own time consumption. Okay, so let's move on to the tool straight away. So what you are seeing now is a command prompt. So I have just initialized one command prompt on the in the Windows for you, and we'll see that I just a few minutes back we had seen that Python environment can be invoked by various different ways. So I will just very quickly show you those three ways other than online, because online anyway you can do go to Programmies as well as many other Python online interpreters and environments. Even Jupyter has got online mode which is possible. So you can carry out those and very easily do those. So other than online, I will just show you at least two or three ways very quickly where we can go into Python. So we are having of course, your Python installation should have all paths properly set up. So what we have to do is just at command prompt, we have to say Python. And as you will see, a 3 greater than prompt appears, which is nothing but a Python prompt. So we are in Python. And probably we can carry out some activities like variables. And in fact, some programming uh, can also be very easily carried out. So it supports everything, in fact. So this is one way of entering into Python environment. I will just exit. Normally, exit is done with the open and close brackets being a function. So I have come back to the command prompt now. And now another way is what I had said, that simple packages which are available to run from command prompts such as interactive Python. So I will run one such package, that is IPython for 2 and 3. There are different versions, so you can explicitly run IPython 3. But anyway, if you run even IPython and only Python 3 is involved, which is the most installed, which is the most common versions now which are available. 2 is almost deprecated, but 3 also has got various versions, and IPython 3 will invoke the currently installed Python environment on your machine. So you will see that I have got 3.8.8 installed on my machine, and that is what starts. So I come to a prompt as compared to a 3 greater than prompt, which is there in basic Python. The interactive Python, we will see that it has got an in and out type prompt. So at in, I can say something, as you will see. I'm saying a is equal to 5. Then I'm saying, say, b is equal to 6. And I will say, suppose c is equal to a plus b. And then if I say c, it will say out 11, which is obviously the total of a and b. So what we are having here is, what I'm working right now is in interactive Python. Okay, so it will give you interactive. It also provides you some additional power with giving some error codes, error messages, a more interactive way of dealing with the Python environment is thus provided by IPython 3, or in general IPython, which is nothing but interactive Python. Uh, Going out of Python environment is just like what was earlier. So you will see that I have again come back to command prompt. When I say exit, open and close brackets. Semicolons are not there in Python for termination. Uh, it is just without any termination grammar which is there. Okay, so this is another method. So what we have seen is that plain Python running from command prompt, the environment directly running from command prompt, and then some simple packages to have interactive sessions on Python from command prompt, that is IPython. And now, as I said, there are integrated development environments which are available. So one such integrated development environment, I have just kept it open for you, and it is called as Spider. Okay, so you will see that this is Spider, which is coming as a tool, integrated development environment tool for Python, and it is also available as a part of Anaconda suite. You can deploy it, you can install it on your machine. So you will see that the same Python environment is running here in its console, which is there on the right hand side. Same Python 3.8.8 April 13, 2021 version, which is running on it, which was there in IPython as well as which was there in the command prompt version of plain simple Python. So we are having this is nothing but working like IPython only. You will see that it actually says that it is IPython. So interactive Python is there, and whatever I did there, like a equal to 5, b equal to 7, and c equal to say a plus b, and then I say C, which will give the total. Is this something? The basic work can be carried out in this IPython also, but in addition to that, I can run or write a program on this side, which is there. So I can say A equal to 5, I can say B equal to 9, suppose. I can say C is equal to A plus B, Now I cannot say just C here because it was the interactive output which was coming. You will see that on this side, a C gave me the value of C as interactive output. But when you are running a program shell, what typically what we call it as we are running a Python script, then such output not be available because in script or in Python program shell, what is output is what we want to output. Okay, so obviously a C will not work. Instead of that, I will have to say print C. Okay, so print C will work, and I can now run this program. Obviously, I will be needed to save this program. Say I will say that it is my first program, and okay, I have created a NIT Raipur lectures. I will say first program dot py, and I am saving it. So I can run this program now. So when I execute, obviously you will see that the result of run file is 14, which is nothing but the addition of 5 and 9, because I have said only print C. But obviously, because now I am dealing in a program, I can say that I want to print all the three things. Okay, fine. And because I want to print all the three things, it will be, as you can see, the execution now happens, and you will see that it is showing as I highlighted it. You will see that 5, 9, 14, all the three variables are visible there. So this is IDE where we can write small and big programs in Python and make them execute. Then obviously when you are in IDE, you will have various options which are there with the run or debug or various preferences. I can save entire Python project with all support files that are needed, etc. So all those things which are typically what you can see with any IDE. If you must have seen the IDEs of C or Java, like say maybe NetBeans or Code Blocks or any other Eclipse, whatever IDEs which are available, or in case of embedded environments, IDEs like Arduino IDE, etc. You will see that it comes with the entire support functionality and accessories which are needed. So bare minimum, obviously, it will have a built-in editor, a debugger, for execution, there will be a Python console or the Python environment, which will be running as IPython mode, interactive Python mode, or in as one of the windows in the Spider interpreter. So all these things will be available to you, and this is another way of dealing. Similarly, you can have PyCharm, you can have other like Jupyter notebooks, and so on and so forth. So there are n number of ways in which the Python environment can be invoked. Now, let's go back for the time being to the interactive Python, and we will see a few things which are related to Python interpreter. And okay, so a Python interpreter has again started. Now, we were talking about what we are going to cover first. As I said, data types. So some very basic data types that Python supports, and then immediately we will move on to do some console IO. So first of all, data types. What are the data types that are supported by Python? As I said, the basic data types which are supported by Python are numeric data types, which can be integers, which can be floating point numbers, which can be complex numbers, or it can be a characters or strings, which are non-numeric type data types. So non-numeric data types, which are supported by Python. So if I say A is equal to 5, B is equal to 7.7, C is equal to equal to, sorry, C is equal to 4 plus 3j, okay, and say D is equal to Shrikant, okay. So I have created different data types, numeric as well as non-numeric. So what are the numeric data types? Let's see how we will identify. So there are functions which can give us what are the data type, and that particular function which allows me to have a look at the data type is called as a type function. Okay, it will tell me what is the type of variable A. Okay, so type of variable A is integer, and if I say what is the type of variable B, it is float. It's a floating point number because it was 7.7. What is the type of variable C? It will say it's a complex number. And what is the type of variable D? And it will say it's a string. Okay. So all these basic data types are supported by Python. Python is a language where you don't have to what you can say assign data type to the variable, or you don't have to declare the variables. In fact, the first assignment automatically sets the type of data for that variable. So the point I said a is equal to 5, it assigns 5 value to a, and it will change, or it will assign its data type to be integer, not like C or many other languages where I have to say something like int a. So I have to declare the variable in a particular data type first. Such things are not necessary in Python. So if I say a is equal to 5.0, immediately the data type of a will change. And if I say what is the data type of a, you will see that now it will start saying float. But if I say a is equal to 5 like this, so in quotes, obviously the data type of a now will become a string. Okay, so data types can be changed for a variable without much trouble. As a programmer, in our logic, we only have to take care of that. We are using data types or interchanging or assigning data types in a proper manner. So that programming discipline has to be with us. Python usually will not have much trouble on that. Of course, if you try to assign already declared variables in different data types, already, sorry, not declared, already assigned variables in different data types, and try to do some matching or equating or uh, assigning from one to the other, which is not having matching data types, it is going to give you errors. We'll see that. So this is as far as the very basic data types of Python are concerned. Just like C or any other standard programming language, it also has functions which can do typecasting. Okay, that is change a particular data type for the variable. So that is possible. So if I say again, suppose a is equal to 5, obviously the data type is integer. But if I say str a, you will see that the out says that now 5 is in quotes because a typecasting or type conversion function has been applied, which is str. And because that function was applied, now the type obviously has changed to, sorry, because I didn't assign it, it is still a is not changed. If I say a is equal to str a, now I have assigned it back to a, the string typecasted a. So obviously now the type of a will be str. Or if I say a is equal to 5 and I will say float a, and again, of course, I assign it to A. It will change it to the floating point number. And if I say now A, it will not show 5, it will show me 5.0. And obviously, if I say type, it is going to be float. So we can use int, which is a function converts a data type to integer, float, which converts the data type to floating point number, string or str, which converts the number to a string. Okay, so that is how it will be. Of course, you can convert any number to string very easily, but you cannot convert all the strings to number because of the constraint that the values which are shown in a string must be numeric. So if I say something like say d is equal to 6.54, okay, and I say float d, it will work. Or similarly, if I say d is equal to 777, and if I say int d, it is going to work. But if I am having a string which is having non-numeric characters, then obviously that is not going to work. So if I say d is equal to 7d, it is not going to work. If I say int d, it will generate an error that it is not having the integer literal is not possible. I am not able to convert it with base 10. Now, why it is saying so? Because yes, hexadecimal number 7d could have been a good number, but then for expressing hexadecimal numbers, we have to write it as 0x. Okay, just like probably what you might see in embedded C, most of the versions they will support hexadecimal writing as 0x. So 0x 7d would have been a valid number. Okay. So of course expressed in hexadecimal. So that is the way what we can see about is that the basic data types, their convergence or typecasting, as we will see, where we can change the data type of a variable from one data to another data type, and a type function which shows you that it is a data type. Okay, what is the data type of that particular variable? So this is as far as the very basic data types are concerned, we can say about this. Next to this, of course, very quickly, we are having all the mathematical operators allowed. So we are having, as you know, plus, minus, multiply, divide. So plus will be plus, minus will be this. Okay, I will not show you example because they are too trivial. Star will be multiplication. Division is of two types. One is slash and one is double slash. One is called as the fractional division and the other one is called as the integral or floor division. Okay, so now what that we will see very quickly these two things. Okay, let's see very quickly these two things. If I say A is equal to 7 and say B is equal to 3 and I say A upon B, it will result in 2.33333, which we already know. But if I say A double slash B, then it will be 2. So it gives you only the integer part of that particular division. So it is called as floor division. And of course, if I want to get the remainder, I will give percentage. So if I say a percentage b, it will be 1 because 3 divided by 7, the remainder was 1. So you can use that. And double star
Excuse
is
me,
for,
sir.
oh, yeah,
Oscar, can you please increase the font size?
it is not visible.
Yes, it's visible, but it's too small to read. So,
but this entire thing is getting on the full screen. Just a minute. What I will do is that then probably I will run this in the ID so that there I can change easily the font size. Even in the window we can do it, but fine. Just wait for a minute. And also the it will become white, so it's easier. Is this same size you are visible or it is somewhat better?
Here it's,
Hello?
sir. Yes, sir. It's better.
Uh, is it better or otherwise? Okay, fine. I will do the preferences and appearance and editor. Editor. Okay. Where is the? Yeah. Okay. Now it seems to be better.
Yes, sir. Thank you, sir.
Yeah. Yeah. So now the font size is good. Fine. So yes, I was up to a point where we had completed the different data types and also the conversion and the type declaration or type assignment which was carried out. And last point, what was that? Where I was? Last point was, yeah, I was showing operators, sorry. So we are having all different mathematical operators which are possible. Similarly, comparison operators. I will shift to, I think, PPT and we'll run through it because they are very standard. So we are having constants, we are having variables. Uh, Variables can be single valued. So we are having numbers which are integer, float, and complex. We have already seen this. Then we are having strings, which can be a single character, multi character. Again, no declarations are required in the a pre-declaration is not required in the beginning. Also, it can be multi-valued or multiple elements, and that gives rise to a host of Python variables called as sequences. So, multi-element data types, that means a particular data type which is capable of holding multiple elements is called as multi-element data types, or also it is known as Python sequences. And now we will see that strings are actually multiple characters elements held into a one particular data variable or memory variable, and therefore strings are also sequences. Also, we are going to see very specific sequences similar to arrays like lists or tuples, and then sets and dictionaries, and couple of few more are there. But obviously, as we are having very much time constraint, we will be seeing very quickly strings, lists, and maybe dictionaries out of it. Sets and tuples being almost similar with some minor variations. Okay, so data types are there. We will come to a point where we will see a specific feature which is there, what calls certain data types to be mutable and certain data types to be immutable. Now, what is it and how really exactly it works out? I will show you when we go to lists. Okay, when I will show you the lists, at that time I will show it to you in a better way, maybe towards the end of the today or maybe tomorrow morning. Sorry, tomorrow evening in the second lecture, we will be able to see these mutable and immutable data types in a better way. Okay, so we are having basic console IO as the next topic. But before that next topic, very quickly, I was looking through the operators, and what were the operators that we saw was addition, subtraction, multiplication, division, floor division, power, and remainder. These were the operators which are mathematical operators, arithmetic operators are supported by Python. It also supports greater than equal to, less than equal to, of course, equal to and not equal to as the operators which are inequality or equality operators or comparison operators. It also supports the logical operators. But of course, the logical operators will be written down in words as and or not, etc. So it will be like this. So if I say A is equal to true, which is allowed as a keyword, so it sets value of A to be true and B is equal to false, again allowed keyword in Python, and B is equal to false, then I say A and B. Okay, capital or small is good, there is no difference. So A and B, obviously it will give false, and A or B, of course, it will give true, and so on. So A and not B, obviously it will give true. So the logical operations can be carried out using and or and not functions. Sorry, not as used as logical operators. You can also do bitwise ORing, which I will not cover at this point of time in details here because bitwise ORing normally happens more so in the embedded area. Of course, when we use Python with RPy, which you are anyway going to do later on in next week, I think maybe second or third week, you will see that such situations might arise where bitwise ANDing is required of the two numbers as they are represented in binary. In that case, we will be using our conventional and then conventional or the conventional not equal to signs which are there. So all those things will be there, but that is for bitwise and bitwise or bitwise not, etc. Logical and logical or logical not is what I have just shown you here. Okay, if an integer is there, it can be treated as a logical assignment subject to the fact that 0 will be treated as false and any non-zero value will be treated as true. Okay, any non-zero value will be treated as true. So if I say A is equal to 0, if I say B is equal to 2, A will be treated, and if I try to do a logical comparison of these, A will be treated as false and B will be treated as true. So you will see that it is returning me 0 means false. Okay, but A or B will return me 2, it is true. 2 will be true because for integer numbers, if I do logical comparison, not bitwise comparison, don't confuse. We are not doing bitwise comparisons here. Logical comparisons, then a 0 will be represented or will be interpreted as false, and any other number than 0 will be interpreted as true. So you will see that these two logical comparisons that we have carried out, the logical operators that we applied are behaving in a right sense. Okay, moving ahead, now we will see what we understand by console IO. So let me for a while shift to the presentation and we will see that basic console IO is there. What is console IO? Console means the console devices that are connected to your computer. So most logically, screen is the standard or console output device, and keyboard is the standard or say console input device. So console inputs are received from keyboard console outputs are given to the monitor screen, and the IO performed with the help of keyboard and screen. That means something that is received as input by the Python interpreter from the keyboard is called as console input. And of course, in the same sense, any output that goes from Python interpreter to the standard or console output device, that is nothing but a monitor, is called as the console output. So combinedly, it is called as console input output or console IO. So of course, now simple program, first program, the hello world can be done, and that hello world can be done by simply saying print hello world. Okay, it is a basic command which is required for doing a console output. So for any console output, the command is print, and any console input, the command is input. Okay, conversion functions I had put here just for this thing. We have already seen this, so we will not again go into that. But console IO, definitely we will have a look a little bit into the console IO. So let's get back to the uh, Python tool interpreter and have a look at what we are saying. So if I say print A, we have already seen it as 0 will get printed. But keep in mind, by default, whatever is inside the print statement or print command will be converted as a string. Okay, will be converted as a string. And that is the reason why we can include all sorts of standard strings in Python here. So I can say the number is and comma and a, and it will say the number is 0. Okay, 0 is a, which is variable, and in string whatever was there, to which I had added value of a, which also gets converted into the string. So the contents of the bracket in print command will be treated, or if they are not, will be converted into a string, and then will be sent as output to the standard output device. That is what the console output will do. So print command therefore becomes quite versatile in that sense, because what is happening here is that we are able to print it in various different ways we can do, and that makes things these two commands quite useful or powerful. I think these two slides got mixed, converted आगे पीछे, but anyway, let's continue with what we are into, and we are having print as the console output. Now, as I said, input will be taken as console input. So I have to say input, and into input I have to give some variable. Say if I say g as a variable, then input g will return whatever you input from the keyboard from standard console input device to the variable. So if I say, obviously I have to return the value to G. Okay. So whatever is inside print, the variable gets printed console output. Whereas whenever there is a console input, we have to return it to the variable. Okay. We will see later on that we are having arguments as what is called as the values which go, or parameters which are passed, and obviously whenever there is a return parameter we have to assign it to a different or maybe even sometimes the same variable. Okay, and inside input again I can put a string. I can say enter a number. Okay, I can say enter a number, and whatever is the value that we will enter when the question is asked will be returned to G. So you can see that in response, it is asking me enter a number. So if I say 45, obviously 45 must have been returned to variable G. But you will see that it is not a number which is returned. So just like whatever is inside the bracket for print, which is console output, is always converted into string. Similarly, whatever is coming from the keyboard as console input is always treated or always received as a string. Okay, so always keep in mind whenever any console IO, that means receiving information from keyboard as the keys gets typed and sending information to the monitor screen as the output. Always the outputs before sending them to monitor are converted into the string. On the other hand, whatever is received from the keyboard as console or standard input device will be always be in the form of a string. Okay, so you will see that here I entered number 45 and it actually got received into variable G, but it is showing it. And I think I don't need to do this, but if I do it, it is obviously going to tell me that the data type is string and not a number. Okay, so if I want to make it a number, obviously I will have to convert it by typecasting. So I can say G is equal to int G, and now G will be 45, which is a number. Okay, G will be 45, which is a number. So this is what a standard input operation can do. Now, very simply, because the statements or functions can be put what is called as cascaded or nested, we can very easily do these two things into a single operation. I can say int input, I can say enter your age, close bracket closing the input function, and close bracket closing the int function. Okay, and then if I say enter, you will see that it is asking me your age, and suppose I enter something like this, you will see that it has gone through. And now if I say what is my variable age, it is showing me 56. And obviously you will see that there are no quotes which are appearing, and therefore the type of that particular variable is actually integer because we have already typecasted it. So the entire input function, whatever was the return value of input function, was subjected to int function, and int function actually typecasted it to make it an integer, and therefore the value which was actually returned to variable age was an integer. Okay, so that is the way it will be operating for input function and the print function. Now this print function and input function together, they make what is called as the console IO, and you are requiring some inputs from keyboard. We will be required to do it using input function, and you are required to send outputs to the monitor. We will have to carry out doing it using the output function. Okay, so you will see that obviously we can do a few things as we what is called as we can do a formatted outputs using print function. Okay, because many times we are required to do a decently legend or properly legible outputs to be generated. We are needed to carry out them in what is called as the formatted outputs. So formatted outputs in the using the print function can be carried out. We can use just a print function, and I will write something. Now I am doing it in a program because I have to run it one shot. I'm saying this is first line. I say just print open bracket, close bracket, will do nothing, but it will take me to the next line. Okay, take me to the next line. And if I say print, you will see that now if I execute this program, I will save it as program 2.py, just they are too small, but still. And if I execute this, you will see that it shows this is first line, then there is one line in between, which is because of that print, and then it shows this is second line. So you will see that I came from first line to second line when the first print function ended. I came to from second line to third line actually in terms of printing when the print open bracket close bracket function was executed, and when actually the function which print function which is there on the line number 10 was executed, one more line was added. As you will see that there is a line after there, this is second line because I already come to a fresh line. Okay, so this is the way these three lines were printed using the print function. So print function has got many other facilities as far as the formatted outputs are concerned, and we will have a little bit of look at those facilities. Okay, so let this be like this. Doesn't make much of a difference for us if it just goes on getting printed again and again. I will move ahead and try to do some formatted output. I will say A is equal to 4. I will say B is equal to 4.45. I will say C is equal to something. I will say pillar. Okay. So C is equal to pillar. Okay. And now I am showing you that I am putting a print function which says that this, so obviously it is going to add a pillar word there. So this pillar I am saying is, then I am saying A, I am saying M, and then I am also adding, okay, so what I'm saying is that this C is A, M in height and B, M wide. Okay, that is what it is showing. So C is a string, pillar will be added. A is, just a minute, a comma is required here. Okay, so now when I execute this, you will see that first line, second line, of course, will come again because I executed it with as it is, and says this pillar is 4 meter in height and 4.44 meter wide. That is what it is showing me as the formatted output. Okay, so this is the way we can do using print command, but we can also do similar way in by using what is called as style, which is what we call it as the C style or legacy style. Okay, and what is that? Let's see. So I'm trying to do a same thing now using C or legacy style. This is just a flat print statement containing the data. I'm just trying to make a copy of that. And I have created a copy of that. So instead of that, now this is a string. So I will say percentage %s, just like what typically we happen to do in C. And here it is part of the string. So I will do that. And then I will say now this is A. A is 4 is an integer. So I will say percentage D. And then for B, I will say because it's a floating point number, I will say percentage F. Okay. And obviously, I have added three variables in sequence C, A, and B. So I will say percentage C, comma A, comma B. Okay. So this is what we are very much conversant. Typically, what we happen to do uh, using a formatter that is percentage sign being used as the format identifier, and then we do the formatted printing in C. So this is typically called as a C style or legacy style printing. So you will see that we are having the first line which is created by the flat print format where we didn't do any legacy so that the string is just complete like that. What difference you can see is that the distance of meter m is good in the second part in both the cases. So it is not going far off. In the first case, there is a gap between 4 and m. That is because we didn't do any formatting there. But here, by default, it is taking some number of digits here as the width of sorry, not width, the number of decimal digits which are there. So similar formatting can be carried out. The C style formatting can be carried out. Again, it is difficult to go further deep into this because again it would consume a lot of time. But what I will do is that just switch to my PPT very quickly. We will see this later on. I will come back, but almost similar example. You will see that we had done. And what is the difference? You will see that now here I am saying percentage S is percentage I or D for integer, and then percentage 2.2f. Okay. So if I do 2.2f, what will happen is the difference that we will very quickly look into our example. So here I will say percentage 2.2f, and now if I execute it, you will see that now it shows 4.45 meters. Okay. So a formatting has been carried out. So this is another way of doing the formatted printing in legacy side. But there is one more style which is available in Python, which is typically called as the string formatter or the method. We will come to this. I am not going to take the object oriented programming because the time is pretty less. But we know that in object there are properties and there are methods. So since, as I said, all the data variables of multi-valued like string or what we are going to see later on like lists, everything, they are essentially objects. The objects support methods. And therefore, here we are having strings method uh, where we can carry out a format, and that is called as the formatter method of the string, and the style is called as the Pythonic style. Okay. So first we saw without any additional information, we did a flat print statement. Then we did it with C or legacy style, and now we are doing it with Pythonic style. So you will see that it is different. Okay, what we are trying to put is 0, 1, and 2 in curly bracket, and the same sequence of variables will appear in the method, and the method is called as the format method, or it is also called as the string formatter. So a format method, and therefore you will see that the entire string is being treated as an object, and a dot comes, which indicates that I am trying to run on this object method. The name of the method is format, and obviously the arguments to format method are these. Okay. Further, I can also specify, as you will see, the distances. Means the formatting can be carried out. Zeroth variable, just a string. First variable, an integer but having 3-digit values. And then, of course, a floating point number with 2.2 format is the second one. So this is what is called as the Pythonic style or the formatter method style, which is there. Okay, so let's try to add one more this method as a formatter method, and that actually will conclude the console IO part for the time being at least. Some additional few things related to this we will come back and see later on. But for the time being, I think that should be good. Okay, so this is my string. Instead of percentage, now I am trying to put open and close curly brackets. And then I'm going to use a format command, that is format method. So format C comma A comma B. Okay, and then of course the close of the print statement. Okay, so you will see that this is another way, and you will see that one more line is added. Okay, that S reh gaya. So actually pillars ho gaya, but fine, we will remove that S, and now you will see that it is coming in the same fashion, but using a different method, what is called as the Pythonic method. Okay, here I can number the format, so we can use arguments, and I can say S, I can say 1 and say 5D. You will see that now the integer width will be 5 digits. So obviously it will going to add some spaces on the left hand side. Okay, and same way I can say that here, and I can say that 2.3 suppose F. Okay, so that is there, and if I do this, you will see that what has happened is uh, 4, which was the variable A, was expressed in format specifier 5D, means it has to be 5 character wide. You will see that 4 spaces have been added before 4. So I can do some good level of formatting. Later on, when I take the loops, I will show you using loops. If I want to print various things one below the other exactly, this kind of methods are very useful, and they find or pave way for good quality formatted outputs. Okay, so that is what, uh, in short, at the moment, I will tell about this. I'll just slightly correct it, and it will look better because there were 3 fractional digits specified. It actually gave me 4.450. So that is as far as the printed outputs are concerned. So I will just close this program because we will move on to a new area. So we will do some new program here later on. Coming back, let us do a few things back to the presentation and get ourselves clarified. Okay, so these are all print formats. Okay, D or I for signed integer, O for octal, small x for unsigned hexadecimal lowercase, capital X for unsigned hexadecimal uppercase, E for exponential, that is scientific format, capital E, F for floating point, C for single character, S or R for string. And of course, if I want to print percentage, there has to be percent. Okay, so percentage, if I want to print percent sign, then obviously it won't get in C style formatter. So if I want to print percent, I think it is very similar to C again. I have to write percentage mark twice. One which indicates that now I have to print percentage as a sign. Okay, so these are the different print formatting commands. Now, Python comes with some very couple of specific things like a single statement. You can do multiple assignments in Python. Similarly, you can do inline swapping in Python, inline exchange of values in Python, which normally otherwise we would be required to do what is called as cyclic exchange. Okay, so A goes to B, B goes to C, C comes back as A. So that is what cyclic exchange is normally required, but inline exchange can be done in Python, although Python actually performs it by cyclic exchange only internally. But inline exchange is possible, and also you can do a chained assignments. That means multiple variables can be initialized to a same value using a single statement. Okay, these things are allowed or facilitated in Python. So let's see very quickly these facilities which are there in Python. So we are having I can do a comma b comma c equal to 4 comma 5 comma 6, which is allowed. So if I say a, b or c, you will see all of them have been properly assigned. Similarly, I can do a comma b is equal to b comma a. Okay, and if I do that, now I again say a has become 5 now and b will become 4. Okay, so you can do inline swapping or inline exchange, and also we can do x equal to y equal to z equal to 7 is allowed. So obviously all x, y and z have been assigned with 7. All three variables have been assigned with 7. So these are the some facilities which I would say that peculiarly provided in Python, where cyclic assignments, chaining of variables, and sorry, non-cyclic or inline exchange, chaining of variables, and assigning multiple variables through single line is possible. That typically allows the Python code to be compressed or modified. Okay, so that is as far as this area of programming is concerned. Okay, so what we have seen is data types, data convergence, typecasting, uh, functions such as type. Then also what we have seen is the console IO, and then we saw two statements or functions which are related to the console IO, that is input statement and print statement. Then we saw different styles of print statement. One is no style or flat way in which the print statement can be given. Second one was a C style or legacy style, and the third one was the string method, what is called as the formatter style, or also called as Pythonic style of printing. And then we will see, of course, this is not possible. This is possible only in the longer course. So we can say take name, age, salary, address. You can do it later on because I will be sharing the PPTs also, and some sample programs, example programs also with you. So take name, age, salary, address from user and display the details. So this is just as a practice problem, a simple practice problem for console. Okay, so now let's move on to the control structures. Okay, so if we say control structures, we are having decision making statements. One is if statement, the other one is if, and else if is actually short form in Python as elif. So ELIF statement, and then of course you can have multiple ellipse and then followed by else statement. Okay, so if first condition satisfies, elif second condition satisfied, and you can go on cascading it. And finally, if none of the conditions satisfy, then else. Okay, Python doesn't have case or switch statement. It is having only if elif structure. Now, someone can think that is it a disadvantage as compared to languages which support case statement? The answer to that is no. Nothing is actually lost execution or machine code wise, because a case statement and a if elif statement sequence structure, they evaluate to a same type of machine code, no difference, not a single line plus minus. But appearance wise, it may look what you can say slightly different. So there could be, like say, those who are very much conversant with case kind of control structuring, they may feel little bit awkward looking at if elif. But somebody who is also conversant with else if structures will find it good. Either way, all of them, in fact, a switch statement, a case statement, and a if else if structures, they evaluate to similar type of machine code. No difference as far as the execution time or speed is concerned. They are absolutely same. Also, what we are having is loops. So in loops, this thing Python supports two types of loops. One is for loop and one is while loop. So we will be seeing these control structures. Okay, essentially the decision making statements and the loops, or other way around, we also call them the conditional statements and the iterative statements. Okay, loops means you are doing things in iterations, and obviously decision making is around doing the comparisons. So these two types of control structures. Okay, and we know that control structures are extremely important in programming for a basic reason that they are the ones which implement logic in your program. Okay, had there been no if or any similar statement or any type of loops, okay, so whenever there is no conditional statement, there is no decision making which is possible, and if there is no decision making possible, your program will become a flat linear program. So essentially there won't be any logic that can be built into the program. Okay, so normally I say that programs do have limited intelligence, and that limited intelligence is because of decision making statement. Anyway, intelligence is all about trying to take decisions. If they are not there, there is no intelligence. So okay, it might be very limited. It won't be definitely natural, but some some intelligence can be exhibited only by decision making. So you need these control structures are the heart of any program or programming language, because what I said, as I said, they impart decision making. Okay, so first we will see a quick look at the if and if then that is if else if elif statement, and then we will also have a look at the loops. But what is the if statement? Okay, a simple if statement is if condition followed by statements, and a more complex structure could evolve with one or multiple ellipse. So you are shown that in a single bracket, and also there is an optional else that is shown with another bracket. That is, so you are having if only just simple flat if is possible, if elif is possible, if elif is possible, if followed by number of ellipse possible, and if followed by one or more number of ellipse followed by else is possible. Generally, else will take care of situation which is not taken care by any one of the conditions satisfied on the top side, on the above side. Obviously, if elif or multiple elif, as well as if elif or multiple elif and else, these conditional statements indicate mutual exclusion. Okay. On the other hand, without using elif and else, you go on putting in number of ifs, they will not indicate or they will not ensure mutual exclusive conditions, or mutual exclusion is not, will not be there. Okay. We already know these are the basic rules of programming. So, but just both can be implemented using if and single or multiple ellipse, with or without followed by else in Python. Okay, so it gives a lot of flexibility, but there are not many or multiple statements in Python. So obviously, this can very easily be verified using any of the programs, and we can take some maybe some simple programs like finding the largest of three numbers using this particular scenario. But again, at the moment, writing down the program, actually it requires at least 5 to 7 or 10 minutes. So it will be very difficult to reach to the designated point in such case. But we can have such programs. Uh, Say largest of two numbers also, we know that we need if statement. So I think very quickly, if in 5 minutes, at least a program with largest of two numbers, we are able to put in, that will be good. So I have to accept three numbers, sorry, two numbers. So I will say I will say A is equal to int. I will assume that cooperative user is there and the user is always entering good integers. So I will say enter first number, then int again, input, enter second number. Okay, and then obviously our if comes. So we are having if say a is greater than b. Now you will see that whenever there is a block, that is something that one must understand and note, take good note of that. So whenever there is a block of statements which are to be followed, the initiator for block is a colon in Python. So Python is language which works on indentation. The meaning is that you will see now, you can keenly observe that it will straight away come to the next line but on the fourth column. And that is because I had put the colon. A colon indicates that indented block is continuing or is commencing. Okay, keep in mind, like Pascal or some other languages, it doesn't have begin and end statements. Similarly, like C, it doesn't have open and close curly brackets. So, a particular block is to be executed if condition A greater than B is satisfied, or any condition in the bracket, or any condition in the statement is satisfied. What we are going to have is identified in Python only by indented block. Okay, and indented block is typically, you can change it in preferences, but typically four spaces or other way around one tab. Okay, now most of the IDEs and even IPython makes this automatic. Okay, you don't have to look into it, but keep in mind, suppose you are actually doing it very much hand coded completely. If you are using four spaces throughout, use four spaces. If you are doing a single tab, do throughout single tab. Do not mix the two. If at all it comes, the onus comes on you, because the loss of indentation is loss of logic in Python. Okay, so I will say if A is greater than C. You will see that again it has gone 4 columns shifted because I am putting another indented block into it. And now I can say that, okay, fine, print. I will say A is largest and maybe what A is. Okay. Now you will see that it will come to the same level. But now I want to do a else condition for if A greater than C. So I can come back by giving a backspace. It will automatically go to the previous indent. Okay. In fact, in Notepad, you are able to see the indentation with lines which are there in the line number area. So uh, different IDs have different ways to show what are the indented blocks. But if you go here, you will see that you can see that there are down arrows. The meaning is that an indented block is following this statement, indented block is following this statement, like this. But anyway, we can say else colon, no condition is to be done. So else colon, okay, what is to be done? Okay, whatever is the logic, we will say that because A was bigger than B, but A is not bigger than C, so we can say that, okay, fine, C is largest and the number is C. Okay, fine. Now it will come here. I will go back. In fact, I want to go further back because now I am writing the else for the first outer if. And I will just try to do things faster by copying the whole thing here. Okay. So I have copied it and the entire indented block has come in here. And okay. So B is greater than C, then B twice C. Okay. So you are having uh, colon which gives you indented blocks. So there are multiple lines or block of statements are to be executed under certain condition. Uh, and this even true with for and while loops. So anytime you are specifying blocks, always the blocks will be indented. They will be identified by same level. They will be identified by same level of indentation and they will be initiated by a colon. Only a single or a simple statement can be without column, but that is we will see tomorrow when we do lists or some other things that how the statement can also be written without colon, but then only it can be a single or a simple statement. A block of statements cannot be there. The point block of statements are to be done under some if or if elif or any other scenario of control structure like for loops, while loops, etc. You will be required, and there are some other scenarios also. We will see them later on. So whenever a similar type of block operations are to be done, they will be indented and they will start or they will be initiated, indicated by a colon. Okay. So anyway, now running this probably could be very trivial. Just a minute. What happened? Actually, I wrote it for 3 numbers here, but again, fine. Forget. The logic was not very this thing. If you want to comment, you can comment with hash. So I will, for the time being, since there was no C, I will I will modify the program and write say elif A is greater than B if now I have got double indented, so I'm coming back to single indented, and I'm okay. So actually, I went and tried to write, although I didn't complete it because I have not considered absolute all conditions as far as three largest of three is concerned. But I talked about largest of two numbers and tried to do three. Anyway, uh, here at this moment, Python is something that is important. But anyway, we should not be wrong by logic. Okay, so any condition remains? Yes, there is a condition remains which says that print. Okay, so there exists a condition. So now it is right. Say if A is greater than B, it says that A is bigger. If B is greater than the A, it says B is greater. And otherwise, both are equal. In fact, because there are only two numbers, largest is not a right word. Okay, so I need to save the program. I will say program 2.py, program 3.py. Okay, fine. So all need to be hashed out. That area of C is completely hashed out now. So hash actually is a comment in Python. Okay. So now what happened? Hmm? Why it is going fundamentally wrong in logic? Something I will check. This is too much. इंडेंटेशन में भी गड़बड़ नहीं है. Anyway, let me come back. देखते हैं इसको मैं चेक करता हूँ. We'll move ahead for the time being. Fine. एकदम कुछ तो भलता ही हो गया. ठीक है. Let me check. Coming back. Fine. Shocking. Okay. I'll for the time being move ahead. Later on, see if there is some small error which has occurred either in program or somewhere there. Uh, okay. Also, Python allows a range test. So, like say 3 greater than equal to A greater than equal to 5. So, essentially, it allows two comparisons to be combined into a single comparison. Otherwise, it would have been two different brackets. Uh, A is greater than 3 and A is less than 5. That kind of double bracket comparisons would have been needed. But Python allows those in a single statement. So range comparisons or range testing comparisons can be carried out in a single statement rather than doing it or splitting it into two. So if I want to have a parser, we can easily write that something is 0 to 10, 10 to 20, 20 to 30 kind of thing. I can write straight away 0 to 10, 10 to 20 like that. So range testing is possible in Python. Okay. Then for loops which are there. So of course again we will have for condition followed by statements. And here also the initiator has to be colon and all the statements should be indented. So we can write say for any character in the string, say hello, print the character ch. Okay, so obviously it will go on into a for loop and do that. Uh, yeah. So I can write here itself for ch in Shrikant print ch. So you will see that you are having uh, Shrikant printed one below the other. Obviously, because the print statement was executed eight number of times, and because print statement got executed eight number of times, every time after the print was executed, the control was taken to the next line, and therefore the word each character of the sequence Shrikant or the string Shrikant was printed each character on a new line. Okay, but actually there is a print command which allows something like we can have a end specifier, and if I say end specifier to be a space, you will see that it can come on the same line. So by default, slash n, that is backslash n, or a new line character is automatically added at the end of the print statement. But if I want to suppress that, and rather than having end character added to it, we can have the end character suppressed, and whatever I want to be end character, I can put that. Like say, if I put comma, if I put comma and execute it, you will see that Shrikant is coming a comma printed against each of the characters. So that is something like again what we can do with some modifications done to the print command. But as far as the for loop is concerned, we are able to execute the for loop in this particular manner. So anytime I want to do something iterative, we can very easily do it and perform using a for loop. Now I will show you very quickly another example where in for loop we will use a for loop, and also we will use a simple print formatting which will be imparted to generate uh, what you can say good results. And what is that? Okay, I will say that I will print one any given table. So I say that no is a number which will be input. I will say enter a number. Okay, subsequent to which we will print the table of that particular number. So if I want to print table of that particular number, what we will do that for I in whatever. Yeah, for I in. Yeah, actually, I should show you this first. See, whenever you are using a for loop, we will be having a instruction given as for, followed by some variable or some condition or some what is called as number variable or numeric variable or even character variable, even lists, dictionaries, anything can be done. And we have to, any type of variable is required to be supplied there, and we have to use in. So when I use in, I can put the particular uh, value, and when especially so it is say when it is numeric, the values can be like something like this. Suppose I say for I in range 10. Okay, what to do? Say print I, suppose. Okay, so you will see that what it is printing 0 to 9, because in Python numbers are started from 0. So the indexes also, we will see later on, the indexes for strings or lists or any sequences, they will start from 0. So when I say for I in range 10, it actually printed numbers 0 to 9. But if I say range 1 comma 10, okay, it will print numbers in the range 1 and 9. Okay, so how it works is, I will show you with one more example. If I say 1 comma 10 comma 2, it will print 13579. Okay, what is the meaning is that you can specify the numbers to be in the range a single value, then it is a stop value. As you will see here, I in range 10. So 10 is a stop value, but it excludes that value. Of course, the start will be taken by default 0 if it is not specified. So only one number specified, it gives the top value. If you specify two numbers, it will take it as start value and stop value. So 1 comma 10 will give you start value and stop value. And again, the start is included and the stop is excluded, and therefore it gave me 1 to 9. And if I say three numbers, then it will be start, stop, and step. Okay, step means separation, or step is a stepping size. So if I say 1 comma 10 comma 2, the step, that is separation, will be of 2, or the step will be of 2, and it will start at 1, it will stop at 10, 1 will be included but 10 will be excluded, and therefore it actually printed 13579. And therefore you will see that uh, for loop can be used for numeric values with function range. Function range is one of the anonymous function, or single liner as we call it in Python. So single liner function in Python, there are many functions, but we will have a look at the remaining functions very quickly when we do the functions tomorrow. But range is one of them. There are two more. Lambda is there, map is there, filter is there. At least three or four are there. So range is a single liner function which can be taken and which can be executed with for loops, and the arguments that particular range function takes, one, two, or three arguments. When it is only one, it is a stop value. When it is two, it is start and stop value. When it is three, it is start, stop, and set. And of course, in all cases, one thing is common, that is start is included and stop is not included. Other way around, if start is not specified, 0 will be taken as by default as a start. Okay, so we can use this here, and we will do a quick work here. So I will say that for I in range 1 comma 11, that means I am going from 1 to 10. So 1 will be included, 11 will be excluded, and I will say print. What I am going to print is whatever number that I have taken, no, multiplied by I equal to, in fact with comma it is going to add anyway a space. So let's not give extra spaces, and no into I. Okay, so fine. So when I do this, let's store this as a number also. So program 4. Okay. So I print says 7, and you will see that it has printed the table of 7. Now you will see that here for loop along with print statement, we were able to print it in a very decent way. But strictly speaking, I have not formatted this. It has come like that only. Okay, I have not formatted it, not taken much efforts to format it, and therefore what will happen, what we are seeing is that 7. Okay, if you see 7, uh, it should have come in the second place, but it is appearing in the tens place. Similarly, 70 has been shifted by 1 because 10 has made the things to shift by 1. Okay, also 10 is not correctly aligned if I talk about the numeric values. So we can very easily do that using some simple things like, what I'm trying to do, I'm trying to use a Pythonic style, and then writing the whole string, and of course trying to do a format on that. Okay, all of them are integers, so I'm using a D format specifier, and of course now I have to say dot format no I no into I. Okay, so you will see that now the thing should be better looking. I will take 7 only. Now you will see that a much better formatting has been carried out. In fact, because the numbers are only 3 digit, I can do this 3 also to bring things closer. And you will see that now 7, 14 up to 70 are properly aligned. 1 into 10 are also properly aligned. So you will see that we can very easily generate, and later on we can see that further. I can have a table of 243. Now you will see that the trouble was there. The alignment was lost. In fact, 4D would have been a correct way, because if I say such a big number, the numbers are going to be big and the proper alignment will take only if I provide four spaces for the output digit. So you will see that a good formatting output can be generated combining for loops. Like say if I want to print tables, uh, then it will be very good to print different rows in tables in a for loop to generate a very good proper formatted output. Okay, we will see that example in pandas and then towards the end when we handle some data set. So at that time, we will use such examples. Of course, constructing the entire thing here will be a bit difficult because the programs slightly tend to become bigger. So I will have to use the programs which have already been done, maybe in my previous sessions, and I will be required to use them, or I will be required to do a cut paste on them. But so that we don't lose much time on that, but I can show you that these two or three things, very basic things, which are related to console IO, related to print formatters, related to for loops, can be used in combination to generate good tabular outputs on the prints. Okay, so this is as far as the for loops are concerned. Moving ahead, in just 5 minutes, I will show you the while loop, and then you can do one program for printing prime numbers from any range to any range. That means, say, from 1 to 100 or 1 to 500 or 20 to 70, whatever are the prime numbers in that particular range. You can just have a print of them and write a program using either a for loop or a while loop as a exercise, and we can start from that point onwards and then move on to Python sequences. So uh, you will see the usage of a range function and the prime function one, but just let me have the while loop completed for the sake of completion. While statement for more traditional loops, like it is very similar to what a C or a Fortran or a Java while loop would do. So you are having a while condition. Again, colon will be the initiator of a block. Block will be indented, and statements and the condition alteration has to take place inside the statement so that the while condition at some point of time becomes false. If it doesn't, then obviously you are entering into an infinite while loop, and infinite while loops are not good because your program will never come out of them. But you will find infinite while loops in embedded programming because most of the things are continuously running there, like say devices. So you typically happen to have things encapsulated in while one loops. So while one is the loop which is always true, and therefore you technically you never come out of that particular while loop. But in conventional or in commercial programming, in application programming, typically while loops should have a statement which will take you out of the while loop. So there has to be a condition alteration happening inside the body of the loop, which makes at some point of time the while condition false, so that you are able to come out of while loop. That is what is intended in terms of while loops. So you can maybe do another exercise. So these two you can carry out as an exercise. One is to print the Fibonacci series, and the other one is to write down prime numbers in some range of numbers, or from one to a particular number. That kind of thing. Okay. So you can also use a break statement in the loop, which allows the loop to be broken if a particular thing is satisfied, or whenever you are having a particular condition satisfied, you can enter a break in the loop. For example, you will see that for val in string, if val is equal to I take a break. So if I am finding character I, a break will be taken, and we are printing the value of val. So you will see that it will print S, it will print T, it will print R, and at that point, you will see that it will take a break. So a break in the loop essentially breaks the loop for good, and the program control is transferred to the statement next to the indented block of the for or while loop. Okay, so there is a for loop or a while loop appearing in the program. The indented block, you will be coming out of it using the break statement. On the other hand, a continue in the loop will allow you that particular iteration to be skipped, and you will move on to the next iteration. So in such case, obviously, we will not be able to print the val I. So it will print S, T, R, and N and G, but it will not print I because that particular iteration is skipped. So in short, in these loops, we will have break command or break statement allows you to break the loop and come out of the loop, going to the statement next to the indented block statement of the loop, whereas continue allows only one iteration to be skipped. Okay, so if you want to skip a loop completely for good, a break statement will be needed, and if you want to only skip the current iteration of the loop, then continue statement will be required. So you will have these two statements, that is break statement and continue statement, which are there used in loops. So I will take the same example very quickly, and we will say for orange, say in Shrikant, if ch is equal to, which is a comparison, and if I say I, ch equal to I colon, then I say break else, and in that case we print ch. So you will see that it is printing S, it is printing H, it is printing R. When it finds I, it takes a break and comes out of. But if I use continue here instead of break, if I take continue here, you will see that it prints HR. At I, it skips it and therefore is unable to print. And then it continues only skipping that iteration and prints K, A, and T. Okay, so that is the way break and continue can be used, as you will see with these two examples which is now visible there. A break and continue can be applied within the for loops. Similar way, in a very similar way, they can also applied in the while loops. Okay, so loops with else clause, for the time being I will just skip. We'll come to the prime number. But okay, so essentially what I have tried to cover is normal speed, two sessions. So I have tried to cover them in one session, and we are already at 1935. So I think we will be needed to close for the day at this particular point today. We have completed control structures. So what we have done today, as far as the basics of Python are concerned, is data types, data type casting, conversions, functions which show the type of the data, functions which change the type of the data in short, different types of arithmetic, logical, comparison, equality, etc. operators which can be used in Python. Console IO with Python using two functions, input and print. Print statement, various facilities provided by print statement in flat method or in flat way, or using Pythonic style, or using legacy or C style. Then we have seen that some peculiarities of Python, like chaining, cycling, non-cyclers or inline exchanges, and multiple variable assignments in single statement. And then we have seen various control structures. So if elif, else, if elif, and without or with else. And then of course for loops and while loops, and using break and continue in for and while loops for skipping the whole loop or skipping the iteration. Okay, so this is the part that we have covered today. Tomorrow, as I will start with the prime number example, and I think I will just look into that while writing. I have mixed up that logic. Actually, it will not allow me to sleep unless that is sorted. Must be some very silly in the heck of it. It has been done. So we will correct those programs also. Uh, but anyway, we will start from the example using else in for loops, which is a really very peculiarity. So using else with for loop, take an example of prime numbers program, and then we will move on to Python sequences where we will cover lists, tuples, and dictionaries, and list, tuples, strings, and dictionaries. Tomorrow, that will be the area that we will cover. Subsequent to sequences, we will also have a look at functions and modules in Python. And in the end, if time permits, we will try to put hands on files. Otherwise, that will go to the third demo. Okay. So thank you from my side for this particular session, and I think we will close with this. Thank you, madam.
Thank you so much, sir, for such an
Mm.
insightful session. And I hope that everyone who was watching, who was with us throughout the journey, would have learned some very insightful things about Python and data analytics. We are looking forward for our very second session tomorrow. So I
Yeah,
request everyone who has been with us throughout to join us tomorrow again in the same
same.
time, and we'll directly
Thank
start sir's lecture.
you. Yeah,
So thank you so much, sir, and thank you so much, everyone. We'll see you
yeah,
tomorrow.
yeah. Thank you. Yeah, thank you, ma'am.